Welcome to tutorial 7, confidence intervals 1. Before we go ahead, let me do a little bit of admin. So the marks you received in right and wrong questions you had and the solutions for LBRT 1 are out now, so you can have a look. When I say solutions, I would say maybe overstated. I think it's the answers are out because each person got a different question. So have a look, see what you got wrong, if you got anything wrong, and try to solve it again, see if you get the right results. Then what else? We have CML3. First attempt closed yesterday. So the second attempt will open on Wednesday, tomorrow, and CML4 starts on the first attempt for CML4 will also open on Wednesday. Make sure, as I said before, for CMLs and LBRTs, try the second. Make sure you do the second attempt, see if you get a better grade. It's always a good idea. See what you got wrong for the first one, then you can do a second attempt. And the LBRT2 will open on the 17th of January, so we still have another week for it. Okay. In general, as well, I mentioned before we start recording, our tutorial group did really well, so I'm very happy. Like, congratulations, guys. Let's keep the quality of and the grades you guys got, the quality of the studies. So before we go to the tutorial, is there any question, anything you guys would like to pop on chat or open your mic? I'll get going, but feel free to do so if you guys have any question. So today we'll be talking about confidence intervals for the first time. So at the end of this tutorial, we should be able to describe the difference between point estimate and interval estimate, determine when it is appropriate to use the Z statistic or the Z table for interval estimation, and when it's appropriate to use the T statistics and use the T table for it. Use the T distribution tables, calculate confidence intervals for population means using Z statistics and T statistics, and calculate confidence intervals for population proportions. So let's get going. And let's start with the first one. Oh, important thing, be ready, because today we have a lot of polls. I might not give you as much time as I did before, but yeah, it's really important that you guys participate and give it a go. Don't worry too much, and absolutely don't worry getting right. Just make your best attempt. And if you don't know yet, or if you haven't had a chance to watch the videos yet, it's all right. Let me launch the first one. The idea here is for you to try, and then we check if it's right or wrong. If you got it right, amazing. If you got it wrong, we will explain how to think about it. So let's start. Let's get going. The first one's already available. I already launched it. For people watching this video later, I had the print of the questions in here. And let me read the question out. I'll give you like a minute and a half or two to answer it, but let's go. A sample of 114 engineers was surveyed, and it was found that the average time they had spent with their current company was 11.78 years. Determine the 99% confidence interval for the mean number of years engineers have spent with their current company. Historically, the standard deviation of time spent with the company is 3.2 years. How would you interpret this confidence interval? So, all right, let's check where to put each of these values, which symbol we're given to each of these values. I have 6 answers up to now. And the values what we're looking for are 114 engineers. Which symbol would we give to it? The 11.78 years. Then 99% confidence interval. I think that one's not too difficult. And the value 3.2 years. You will see that they are most of them are different phrases. So think well about what to do with it. I have only 11 answers up to now, and we have 19 people that could answer. 12, 13, it's going up a little bit. I'll give you maybe another 10 seconds. 14 answers up to now, missing just 5 people. And that's it. I'll win the poll. Amazing. Share the results. So we have 15 answers. Good. Just missed 4. So what do we have? First one, I think it's pretty simple. We had it was talking about a sample of 114 engineers. So we give the 114 the little n, which is the sample size, right? For the second one, 11.78 years. We are giving an X bar, a sample mean, because it's saying that this 11.78 years was found by that survey. So using the sample that we have. So a sample of 114 engineers was surveyed, and it was found that an average time they had spent with their current company was. So the survey using the sample found this number. That's why it's in this side of the screen. Then we have the 99% confidence interval, which is here. Quite simple. Let me just mention for the first question, 11 out of 15 got it right. Amazing. The second one, a lot of people said mu. Only 4 got right with saying that it was an X bar, which it's a normal confusion. It's normal to get them mixed. But in this case, we're talking about something coming out of the sample, right? Next one, for the level of confidence, only 7 out of 15 got it right. I thought this one would be a little bit more straightforward since it's talking about confidence interval. So I thought, okay, confidence and confidence. But yeah, that's all right. No, not a problem at all. And for the next one, what symbol would you give to the value 3.2 years? And I thought this would be tricky. But 10 out of 15 of you got right. Amazing. In this case, it is talking about the population, because it says historically the standard deviation. So it's not our survey, it's historically. So that is it. I'll stop sharing. Good job, guys. We'll move to the next question, and it's another poll for you to make a decision on what we are going to do with the numbers we got. I think I'll give you just maybe a minute to do this one, because it's pretty simple. I'm just asking what type of exercise we have here. So what type of problem is it? It's still the same problem, right? So is it a seagull, so a pelican, a shag, or a freaky fish? And I left an advice saying how to identify. The seagull, it's just one little fish, so no sample. The pelican, it's a sample, so a few fishes in there. And sigma is known. For the shag, this little guy here that we just met in tutorial 7, the sigma is unknown. We don't know sigma, but S is known. So we have the sample standard deviation, but we don't have the population standard deviation. And finally, the freaky fish is when we're talking about proportion, right? Then based on what you chose here, let's see what you choose, which table we're going to use, and what is the value of alpha. So maybe you guys know, maybe you don't know yet how to calculate alpha. Let me see. We have 7 answers only out of 20, 9 answers now. I will give you another 15 seconds, maybe. I wasn't planning to spend too much time on this one. Just 9, 10 answers now. 11. So probably a few things you might have to look back on your classes, but I'll give you, like, the good news is we're going to use it again and again. I'll be asking the same, and particularly this question, it's exactly the same for every time I use it. Okay, we have 15 answers, another 5 seconds maybe. 15 out of 20, just 5 people missing. All right, I'll end it. And I will share the results. So what's going on here? 1, I can see, oh, that was a close call. It was even between the pelican and the shag. And good job, you identified that we have a sample here. We're talking about a sample, so it's probably not the seagull. We're also not talking about proportional, so definitely not the freaky fish. But this is what we need to learn today. How to differentiate. This is one of the things we need to learn. We know sigma, which is the standard deviation for the population, or do we only know the standard deviation for, oh, let me click once more so we have the answers. Or do we only know S, which is the sample standard deviation? In this case, it's saying historically the standard deviation of time spent, blah, 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 3.2. So we know sigma in this case. So, which means in this, we are working with the pelican, okay? So if it's a pelican, then we can use the Z table. And what is alpha, and how do we calculate alpha? I can see Z table 1, 9 against 6. For t-table, and alpha is basically the confidence interval, or I would say 1 minus the confidence interval. In this case, the confidence interval is 0.99, but if you want to talk about in percentage, it's 100% minus the confidence interval. So 100% minus 99% is 1%, and if we put in on numbers, it will be 0.01. Maybe I should have left 0.01 here. But that's it. Thank you. Good job for good job with your answers. Thank you for participating. We'll close and let's go. How do we solve it? Now that we know that this is a pelican problem, let's put the data that we have together. It's all in here. So we know little n, we know x bar, we know sigma 3.2, we know the level of confidence 99, and which comes from the confidence interval. And we have alpha, which is 1 minus 0.99, which is equals to 0.01. If we're doing a Z transform and sending this data to a Z table, look at it in this part here. Let me click once. We could paint, since we know this guy, then we can say, oh, this is the area, and we're talking Z is symmetric, so it's half each side. And here we're doing a two-tailed test. We will explore it better in the future, but it's a two-tailed test. So there will be a little bit in here, and there will be a little bit in here, right? So let me click so we can pop. How much is the value that we have in this little space? Look, this is, if alpha is the difference, is the area that was left. And if we have two areas that are equal, basically the rest of the area is alpha divided by 2, right? So the alpha was 0.01, therefore this little area is 0.005. And this area here is half of 0.99, which is 0.495. All right? Then let's think about, if we know this area, can we find this Z crit, this value here and this value here? I think since 0 is in the center, these values will be the same, but this one will be positive because it's to the right of 0, and the other one will be negative because it's to the left of 0, right? So I'll click once again. Can I please have on chat the value for this area here? Let me open chat so I can follow. Can someone please help me to see what Z-crit we find for this area? 0.495. Amazing. Thank you, Harry. Anybody else? So I think you guys already have you already have some practice with it. Let me go. This case is one of those cases that it's slightly more challenging. So 495, let's go through the table somewhere around here, previous line, 495. It would be here. The thing is, there's an equal distance between both. It's the middle, right? So we know it will be 2.5, but it is either here or here. And what do? When it's exactly in the middle, we get it. We add both and divide it by 2, something like that. And we get 2.275. So Harry, good job. That was the right answer. So let's go. Now we know this is a 2.575 and minus 2.575, right? Now, pretty much what we're going to do, as we saw before, this is just a rearrangement of the formulas we had. And we're going to put as if we put the mu outside to calculate the interval. So mu is equal to x bar plus or minus zero Z-crit times our sample standard deviation. In this case, look how I'm going to draw it here. So x bar plus or minus Z-crit times our standard deviation, the sample standard deviation, which we calculate during sigma divided the population sigma, population standard deviation divided by the square of n. Okay. Right now we have Z-crit, we have x bar, we have sigma, and we have n. So we can calculate. Now we'll click once again. Here's the number. What time is it? I think we're all right with time. So I will do it on the, let's see if I can get the same results in a calculator. 11.78 plus 2.575 times. And now because there will be a division there, I'll open bracket 3.2 divided by 114. This one I can play with. Square root, close. Can you see 30? Oh, I did something wrong. Okay. Well, apologies for that. 11.78 plus 2.575 times, let's open it, 3.2 divided by 114 square root, close bracket, equals. So 11.55 should be our top, 551817. And let's see what is the bottom. 5517. It's rounded to 552, which is fair enough. We could have rounded. And the bottom one, 11.008. I will probably spare you from those calculations in the using the calculator. I think by now you guys have these things under control. But this is a little bit just an example of how we could do. Okay, you could use something else if you wanted. And that's it. This is the answer. But we asked something else. How would you interpret this confidence interval? And this is an important thing to when we're doing inference statistics, because this is, we believe, this is how we found out the population parameter, mu, so the population mean. And look, one suggestion of how to do it. Based on the sample mean that we have, so we received a sample mean. We did a survey and got a mean. The mean number of years all engineers, all because it's the population. So the mean number of years all engineers have spent with their company is estimated with 99% confidence to be between 11.008 and 12.552 years, right? So this is a suggestion. It can be a little bit different, but there are things for us to pay attention. Look at this. The mean number of years, our variable of interest, right? Look, where is the question? Determine the 99% confidence interval for the mean number of years engineers have spent with their current company. That's what they're asking for. So it's there. So it's important to say it's estimated because we didn't have a value for mu. We have just an estimation, and we created a confidence interval, right? And we mentioned the confidence interval that we use, so 99% confidence, and it's between pretty much the answer in the end. All right. Any question before we move to question number 2? Let me see. Feel free to send it on in the chat or to open your mic. It might be a little bit, if it's the first time you're seeing it, make sure you have a look at the videos we have, the call prepared, especially the YouTube videos. You will see him, while I use a lot of slides, you will see him doing it by hand. It might be helpful to see how he does it. The order of the steps we do are the same, but maybe seeing someone handwriting things might be helpful, okay, just as an option. But I strongly recommend having a look at other videos too, especially the lecture ones. That's it for question 1, I believe. Let's see. Question 2, another poll. It will be the same way. One poll, we figure out the values, and then a second poll, okay? So I'll launch the first one, and maybe in 2 minutes, let's try to get it done in 2 minutes, and I'll read the question with you guys. So, Mrs. Wilson is considering running for mayor in her town. She decides to conduct a survey before completing the formalities of putting her name forward. Of the 80 randomly selected people surveyed, 48 say they will vote for her. Find a 90% confidence interval for the proportion of all voters in this community who will vote for Mrs. Wilson. From your confidence interval, can you determine whether or not she should run for mayor? This last question we will do in the end, but let's try to see where should we put each of them. It's talking about proportion, and the question number 3 can be a little bit tricky. I tried to make it slightly trickier, but the question number 1 or 2 are pretty easy, I would say. So what symbol should we give to the value 80? Let me see how many people answered at this point. False. I have 12 out of 22. So like, it's still missing 10 people. I'll give you another 30 seconds. 15 out of 22. Good. What symbol would you give to the value 80 random selected people? Right. 2. What symbol would you give to the value 90% or 90% confidence interval? And 3, what is the value of B hat? Okay. All right. I will close the poll. 18 out of 21. Amazing. Just missing 3. And I'll share the results with you. Share results. So this would be the answers. And look, interpreting the question, as you've seen, is really important in this course, and it's the deal breaker between getting it right or wrong, right? That's why I'm testing you over and over on it. So first question, what symbol would you give to 80 randomly selected people? 15 out of 19 people got it right. It's little n. So this is the part of the survey and the amount of people being surveyed. So it's the sample size, little n. Second question, 90% confidence interval. I see that 10 out of 19 of you chose the right one. Level of confidence. I can see it could be a little bit tricky with the other options we have, but pay attention that it's saying 90% confidence interval. I had it just 90%. I took the confidence just to make it slightly more difficult this time, but good job. If you didn't get it right, it's okay. This is the hint. It's talking about confidence. And the third one, and look, almost half of you got it right. Very good job. It's 0.6. And where does it come from? It comes from, let me click one more time. Whoop, no, I'm not clicking one more time because there's another one. It comes from, it's not multiplying, dividing 0.48 by 80. So out of the 80 people surveyed, 48 said they would vote for her. So this is 48 is 60% of 80, so 0.6. Maybe you needed a calculator to calculate, but I put the other numbers very similar, so I would make it tricky for you. Don't try to make it easy, right? But good job for both the people who got it right or wrong. I'll stop sharing to launch the next one. Exactly the same question as before, but well, now we have a B hat, right? What do you guys think? Like maybe a minute and a half for this one? Yeah. Let's go. So what type of problem is it? Is it like population main but with no sample, just one fish? Is it a pelican? So we would know the sigma. Is it the case? Another one about population mean, but would be the shag, which we don't know sigma or the standard population standard deviation, but we know the sample standard deviation. This would be the shag. Or is it a population proportion? And then it would be the freaky fish. And based on your choice here, let's choose if we're using the Z table or the T table. And finally, what is the value of alpha? You guys have just learned how to calculate alpha, right? So let's see how you're doing with the poll. I have how many answers? I have 13 answers at the moment. 14. Another 20 seconds, 15 answers. That's really good. 16. So we need to choose one of these guys. And based on it, you choose whether we use Z or a T table. And finally, calculate the alpha. And that's it. I'm about to close 19 answers. Amazing. I'll end it and share the results. So for the first one, now I can see most of you chose the shag. Maybe I was pointing towards a little bit and like the intonation I use, but it's actually a freaky fish problem, because we're talking about, you will see that we're talking about proportion right here. So this is what we're talking about. So given it's a freaky fish, it's a proportion problem where we use a Z table again, and the alpha is just the difference between the 90% and 100%. I should definitely, for the next time, I'll fix it for the next tutorial. Instead of using percentage alpha, we usually use the 0 point something. So yeah, but for this tutorial, I won't have time, so we'll keep doing percentage. Okay, so you got it right. Z table 12 of 19 and Fantastic result. 13 people got right that it was 10%. Good job, everyone. I'll stop sharing and let's go. So this is what we have now. We know it's a population proportion. So these are the slides we have from the lecture. Can you guys see it? Maybe I don't know if the camera is on the way. I'll put the camera a little bit smaller. Freaky fish, my favorite. And so we know that it's oh, I left the engineers there. It's not engineers, it's people interview for the little n. B hat, it's 48 out of 80, so 0.6, that's how we calculate it. LOC, level of confidence, it's 90% or 0.9. And alpha is 1 minus 0.9 equals to 0.1. Let's go. So Z table is here. So we know it's 90%. So look what we can paint. Same as before, 0.9. So a little bit split in half. We know pretty much how much are the rest of the values, right? So 0.1 alpha. Alpha is equals to 0.1. Therefore, half of the alpha will be 0.05 in each side. And this one is just half of this. So 0.45. Okay. Let me check the chat if there's any question. Not yet. But we're going to look now for 0.45 in our Z table. Z table. Oh, and there we go. Can I please have on chat your answers for 0.45? Spoiler alert, we will fall into the same situation we had before. 0.45 lands in the middle of two of our observations. Yeah, thank you, Harry. Anybody else? You guys attempted it at home? So, amazing. Thank you, Jesna. So let's go. You will be looking and you will fall somewhere around here. And we have two values there, all right? And it's exactly, thank you, Yoshi, good job. Exactly in the middle. So just 0.005 to the left and 0.005 to the right. So we're going to use both. The line is pretty clear. Oh, my computer froze up for a little bit. Yeah, it's back. So the line's pretty clear, 1.6, but then we get to here, which is two columns, the 4 and the 5. And that's when we get the middle, right? 1.645. Good job, the three of you guys. We'll send it in a chat. And let's continue. It's interesting to see how similar. Sorry, let me just put. So we have 1.645 minus 1.645, same way we did it before. Although we're doing the freaky fish, it's very similar to the pelican problem we did before, right? Not a big difference. Let me click up to here, still quite similar. So instead of the X bar, we have the P hat, which is kind of the measure of centrality. So it's the mean. This is not a mean, this is a proportion, but that's what we're talking about, the measure of centrality of our observations, right? Then we have the Z crit, exactly the same, still same format, and we have our sample standard deviation. So this part looks exactly the same as we did for the pelican. The only difference now is that this sample standard deviation has a slightly different formula when we're talking about proportion. So it will be this bigger guy here instead of what we had before, okay? So it's p hat times 1 minus p hat divided by n. All of this, you take the square root. So I will click. We have all those values now. It's 0.6 for our p hat, 1.645 for our Z crit, and our sample standard deviation, we can calculate here. I will save you from seeing me like doing things wrong on the calculator, and I'll just click. This is the value for P. So it's the population proportion, not the sample proportion anymore. So that's why this P doesn't have a hat. And we found 0.5099 and 0 as the lower part of our confidence interval, and the highest point of our confidence interval is 0.6901. Okay, so there was point estimate that we calculated before. Now we're calculating a confidence interval with the lowest part and the highest part. That's what we did in the previous exercise. That's what we're doing now. So, and how? And then it's saying, what is it? Where is it? How we interpret? I think it doesn't say in this question, but let's write it down. Based on the sample proportion, or the proportion we found for our sample, we have 90% confidence that the proportion of voters who would vote for Mrs. Wilson is estimated to be between 51% and 69%. So it's relatively similar to what we had for the previous question, but now it's talking about proportion. The phrase is in a slightly different order, just so you can get a feeling of what we can do. But look how it's still the same. So we're talking about how much is the confidence, 90%. We're talking about what we were looking for, the proportion of voters who would vote for Mrs. Wilson. We're also saying that it's estimated. This is not a thing for sure. We estimated based on our sample, and the value, which is 51% and 69%. Okay. Up to here, last part. From your confidence interval, can you determine whether or not she would run for mayor? And I will just have a little click. I think there was one slide after this one without giving the next answer. Yes, there is. Cool. So based on the sample proportion, we have So these are the things to pay attention. And now let's have a look at whether or not she should run for mayor. And I would like to ask you guys, can you put on chat, what do you think? Should she run for mayor? Or based on what we found, she's better not put her name there because she doesn't have a lot of chance of winning. What do you guys think? Just say, just like yes or no. I'm happy with yes or no on your chat, but I would like to have a lot of answers. Amazing. Thank you so much. I have 3, 4 answers already. 5, 6. That's great. Can everybody give an answer if you guys are there? I hope you guys still there. Fantastic. I want to see like, yes, a wave of answers. That's amazing. So good job. Very good job. What happens is we found between 51% and 69%. So we have 90% of confidence that she will win, because to win, it needs to be more than 50%, right? So since she should be confident of winning over 50% of the votes, she should run for mayor. That would be a good advice. That's it for this one. Any question? Very good job, guys. Thank you for interacting and sending your answers. Maybe we are good on time. Actually, yeah, pretty all right with time. So let's go slowly for the next one. Question 3, another 3 polls, one for each of the items. Sorry for that. So let's go, question 3A. Let's launch it, and I'll give you guys maybe 2 minutes, maybe between 2 and 3. So let's go. What are the important characteristics of the student T distribution? And before we discuss that, I would like you guys to have a go. You will see that all questions have the same options. So pretty much, I just want you to, for each question, find the answer that associates to that one. So what is the mean of a T distribution? Are the values in the T distribution positive or negative? What is the parameter of the T distribution? How do we calculate the degrees of freedom? So if you pay attention to all the questions, they are all kind of linked. So you might use one question as an advice for the other one. Let's see how the poll is going. It's been 1 minute and I have 8 answers out of 22. There's a lot of people still to answer. 14 people. I'm waiting for it. There's a little bit of thinking to do, of course, with these questions. So what is the mean of a T distribution? You have always positive above the horizontal axis. You have negative and positive both sides of the horizontal axis. You have degrees of freedom. You have 0 and you have n-1. So what do you think is the mean of a T distribution? And think about what answer makes sense for this kind of question. And work out the same for the other ones. I have 16 answers out of 22, just missing 6 people. Maybe I'll give you another 15 seconds. Well, how does that sound? 18 answers, just 4 of you missing. Another 10 seconds. For the last 3 people missing. And that's it. 19 answers. Excellent. Thank you so much. So I'll share the results. So what is the mean of the T distribution? We have 7 people said the right thing. 7 out of 19 got a 0. So the T distribution, like the Z distribution, has a mean on 0. Look at that. Let me try to get this thing out of the screen. I won't be able to. So I'll just take it off from my screen. So look, the mean is 0. It's always positive above the horizontal axis. As you can see, it doesn't cross this horizontal axis. It's always above 0. What is the parameter of the T distribution? I said the parameter. There's more than one, but in this case, we're talking about degrees of freedom. I could have written it slightly better. And how to calculate degrees of freedom? So a little bit of an advice from the previous one. It is n-1. So let's see. For the first one, 7 people got it right out of 19. For the second one, there were only 3 correct answers. 13 out of 19 thought it would be both negative and positive. Tricky, right? You're very right somehow. I understand why you would say negative and positive. The T crit could be positive and could be negative. Let me think. But when we're talking about oh, look, I'll tell you, you're right. I think I could have written the answer in a better way. So the values, like the area, it's only positive in the distribution, so it's only above. But the little T crits that you find can be negative. So maybe I'll give you that one for you guys. I think I could have written it better. Third one, the parameter is degrees of freedom. 8 of 19 of you got right. And the last one, 11 out of 19 got right. It's n-1. Fantastic. Thank you so much. And let's go. Second one. No, sorry. Let me talk a little bit more about the T distribution. using this one. So this is has a family of symmetrical bell-shaped curves. So it is a bell-shaped curve, but it's not just one distribution like the Z. There are a few of them. And why is that so? Because we have different values for our parameters. We can choose different different degrees of freedom, and we can choose different alphas that we're looking for. So both of them are parameters, and that's why it's a family of symmetrical bell-shaped curves, not one bell-shaped curve. The mean is 0, as I explained before, always above the horizontal axis, which means the probability is there. So when you have a probability distribution, it's always above the horizontal axis. But if for question 2 you thought, I understand why you thought negative would be the part of it. And it goes until infinite in both directions. Z tables are the same, they go into infinite. The only way of getting 100% is all the way to the minus and plus infinity. And now the parameter degrees of freedom. Okay, so question B, let's launch another poll. So now we're comparing the Z distribution with the standard normal distribution. Oh, sorry, that's the Z. We're comparing the student T distribution with the standard normal distribution, which is our Z distribution, right? So which distribution is taller at the mean? So when we have this, both of them have mean 0, right? So which one is taller at the mean? Which means their probability distribution. You guys, where the curve is, which one is taller? So then, which distribution is fatter? Oh no, I should have said has fatter tails. I need to fix that one. Sorry, apologies for that. And either Z or T, or it's equal. Then the other one, which distribution has more variability? So their sigma is bigger than 1. Sigma bigger than 1. Standard deviation bigger than 1. And finally, when does the T distribution approaches the Z distribution? At the moment, I already have 15 answers, 16. Amazing. Maybe another 15 seconds, I think. Should that be all right for the last ones? I'm missing only 6 people. So let's go, guys, another 10 seconds. So we can start discussing. 17, 18, 19. Fantastic. Just missing 3. 3, 2, 1, go. 20. Oh, answers. That is fantastic. 22 out of 22. It's probably a first in this tutorial. Thank you. So everybody got an answer. I just shared, and this is how it works. I have no space for answers, so I'll just, I don't know what to do with it. Which distribution has is taller at the mean? The standard normal distribution is taller at the mean. You will notice that the T distributions there's a little bit shorter at the mean, but they have fatter tails. So while the T distribution tail goes down here, you'll see T distributions go above at the tail. That's what we call a fatter tail. And the mean, at the mean, the Z distribution is the tallest one. Okay, so T here and Z here. 13 out of 22 people got it right for the first one, and 15 out of 22 people got it right for the second one. Congratulations, you're doing really good. Which distribution has more variability? If you remember, Z, the standard distribution of Z is 1. Therefore, it can't be Z. So it's T. T has a standard distribution bigger than 1. Only 5 people got this one right. but that's all right. And finally, when does the t distribution approaches the z distribution? When it increases or when it's a bigger sample. Congratulations, that is really good. This was a split, 11 each side. The thing you will see, this is how you look when you're looking at your lecture and you see this graph. Look, the more degrees of freedom you have, the more the curve approaches the normal distribution. And we will see it later that, and it's written in here, that's a little bit why we can, after the n is bigger than 30, if you're looking for the population mean, we start using n sometimes. It will be really clear in this course how to use. But when you have a massive sample, like 1,000 observations, we don't even think about t a lot of times. If you're doing the calculations by hand, we might go straight with z because the t distribution is so similar. The numbers are so close that you just go straight to z. But for now, in this course, we will let you know which one to use. Okay. Finally, last poll, and this one pretty quick. Let's go. Stop sharing. Go back. 3C. I hope you guys are having a little bit of fun with the polls. So only 3 questions for this one. When is the student t distribution used in the estimation? And we talked a little bit about it before. Which distribution we use when sigma, or the population standard deviation, is known? Is it z or is it t? Or is it equal? I said it's the equal. Not good. Then 2, which distribution we use when sigma is unknown? Then a little bit different. Is it z or is it t? Finally, which distribution is more flexible in regard to the population being normally distributed? And if you guys are not 100% sure about it, I will explain what I mean. So when we don't know if the population is normally distributed or not, which of the distributions is more flexible? So like it adapts to the fact that if it is or not normally distributed. Normally also is missing an L. I prepared these quizzes today and there are a few mistakes. It's the first time I'm using this set of quizzes. So I apologize for the little mistakes. I already have 18 people out of 22, maybe 10 seconds for the last 4 that we're missing. I'm very happy that I got everyone for the last one. So I have my hopes high to get everyone again. Just missing 3, just missing 2. I think that will be it. Just missing the last 2. 3, 2, 1, and poll. Fantastic. 20 out of 22. I will share the results, and I will also share the answer. And I put a few interesting stuff in there that I can talk about, some fun facts too. So which distribution we use when sigma is known? So remember, we used during the Pelican problem, we used the Z distribution. We chose the Pelican because the sigma was known, so the population standard deviation was known. When it's not known, when the sigma is unknown, but we know the sample standard deviation, little s, then we choose the shag, and with the shag goes the t distribution. Then we use the t table, right? And which distribution is more flexible in regard to the population being normally distributed? It's the t distribution. So you will see, you remember from the lecture that we have this little thing. When we know sigma, we use the z table. When we know little s, we use the t table. And the t crit and t table, they go pretty much in the same place as the z did. Let's go to the proportions. The first one, Z distribution. Well, you guys 14 out of 20 got right. So congratulations, very good. For the second one, 13 out of 20 got T. So pretty good too. And for the last one, T distribution 9 out of 20, it was pretty well split in between the three answers. I know that was a pretty tricky one. But there were more people with the right one than anything else. So congratulations, all of you. If you didn't get it right, I hope the explanation was enough. If it wasn't, please send it on a chat or open your mic, so I can explain it again. So we close the share. Some other interesting facts that I thought, the guy who invented the T distribution, kind of, at least for the English language, that's what Wikipedia says, he actually couldn't use his name to publish his this distribution that he invented. His name was William Gossett, and he worked for Guinness. Do you know, if you guys know, in Ireland, this very traditional island beer that is a dark beer called Guinness, massive brand. So this guy used to work there. But when Guinness apparently didn't allow him to publish with his name, so because other beer companies would find out that they were using a statistician and would probably hire another statistician for them too. So in order to keep their market advantage, Guinness only allowed him to publish the results as with the name student. So feel free, there is a YouTube from SciShow talking about it. I put here, there's the link, but you can just Google the name and you can have a look at Wikipedia. It's a really interesting story, in my opinion. Okay. What else? Let me check the chat if there's anything. Nothing yet. So let's go. Let's go for the next one. Question 4. Let's allocate our variables. Is that okay while I read? So 4 questions, you see the answers are the same. We're just allocating each of the values. You will notice that I'm not asking anything about the air conditioner yet, because we'll be for question B, part B. So I'm just asking things up to part A, okay? So let me have a read. I think I've launched the poll, right? So let's go. A real estate assessor for a local government is studying various characteristics of single-family houses. A random sample of 70 reveals average house area is equal to 175.9 square meters, with a standard deviation of 38 square meters, and 42 have air conditioning. So A, find the 99% confidence interval for the average house size. Interpret this confidence interval. What assumptions has been made? What assumption has been made? What effect would increasing the sample size have on the precision of this interval? Okay, let me have a look. We have some values there. We're not talking about 42 yet. We're talking about the sample size, which is 70. Oh, I shouldn't have said that. Random sample, 175.9 square meters, 38 square meters, and 99% confidence interval. I have 15 answers, 16. I'm missing 6 people at the moment. Another 20 seconds for you guys. Just missing 5. So what symbol would you give for the random sample of 70, for the 175.9 square meters, for 38 square meters, and 99% confidence interval? I'm still missing 4, just 18 answers. I'll close it in a few seconds, and I will close it now. Good. 18 answers, that's great. Share results, and let's go. So look at that. In this case, we have nothing talking about population. We're talking everything related to sample and what we found. And usually this is what happens unless you're doing a census, like Australia does, I think, every 5 or 10 years. Unless you're doing a census, usually the only information you have is what's coming from the sample. So this is quite a general case and something that we might find a lot in the future in this course and in future courses too. So let's go. Oh, sorry, share the results again. I closed for, I don't know why. So the 70 is little n. I can see 15 out of 18 of you got it right. Congratulations. But 175.9 square meters was X bar, and 8 of 18. It was a split decision between you and X bar, but one more extra person got it right. So congratulations. In this case, it's part, so 70 is here, saying the random, but so 175.9 square meters was an average found by serving the sample or going there. So it says the random sample 17 reveals. So both the average and the standard deviation are revealed by the sample. So that's why they're both in the sample size here. So n x bar and little s. And finally, the 99% confidence interval. Let me see, little s. Not a lot of people got it right. Just 6 out of 18. There was a lot more, 11 out of 18 towards sigma. But in this case, because it's coming out of sample, that's why. And finally, for what symbol would you give for 9 out of 9? 15 out of 18 people got right. And sorry for that. And that is it. I think I just spoiled the answer for the next one. Hope not a lot of people were able to see. Let's go. Second question, same as usual. I don't think you guys will need a lot of time for this one. But yeah, let's see what kind of problem it is now. And if we're going to use the Z table or the T table, and what value of alpha we're going to use. I have 5 answers up to now out of 22, 6, 7, and 9. So what did we find different for before? Before we used the pelican, then we used the freaky fish. Is it the same as the first question? Is it the same as the second question? Or is it a little bit different? Given your answer, are we using a Z or a T table? And finally, calculation of alpha. I would expect by now, it's the third time we're doing it, so you guys are killing it. You really know how to calculate alpha, right? I have 17 answers, like maybe another 15 seconds for the last 5 people. 18, 19, missing 3. Let's go. Just the last 3. You guys have 7 seconds. 5 seconds, 3 seconds. All right, 19. That's great. I'll share the results. And let's go. So this time we're talking about the shag. We're looking for a population mean. Again, it's not a proportion, still a mean. We have a sample, so it's not a seagull. A seagull, and we don't know sigma. We only know S. We only know the sample standard deviation, not the population standard deviation, right? So that's why it's a seagull. Let's go. 10 out of 19 of you said it was a pelican. It was tricky. Just 7 got the shag out of 19. Good job, guys. So what is the table we're going to use? 12 out of 19 got a T table. So pay attention. Out of the 4 guys we have, 3 of them uses this. Let me use the annotate here to make sure it's very clear. 3 of them use the Z table. The only one of these guys who use a T table, whoa, my computer, very sorry, my computer froze a little bit. The only one who uses a T table is the shag. Okay, so it wouldn't make sense for you guys to say it's the shag, like 7 of you said, and then 12 of you said it's a T table. So you only say it's a t-table when it's the check. Good, we're good with this. And finally, as anticipated, you guys are killing it with alpha. 12 out of 19 got 1% alpha. Good job, very good job. I'll stop sharing and let's get going with our exercise. All right, so let me close here. This is the information we have. So little n is 70 family houses, x bar, our sample mean 175.9 square meters, our sample standard deviation little s 38 square meters, level of confidence 99%, and alpha 1 minus 0.99 equals 0.01. I just put these little slides here for the check. So we have a level of confidence 99%. We've done it before. Look at the little difference we have here. Now it's a t, it's not a z anymore. It's a little t, but it means it's still 0 as we saw. So I'll click, we have calculated, so 0.99, half of it 0.95495, and each of the tails will be 0.01 divided by 2, 0.005, right? And our t-crit, how do we calculate it? Oh, look at that. It has, I put it repeated. Sorry, little mistake there. So it's a t, and we use the alpha that we want divided by 2. So just this little guy here. And we use the degrees of freedom. Degrees of freedom, remember, it's an n minus 1. So degrees of freedom will be our 70 minus 1, 69. 70 minus 1, okay? And now we're going to look at a new table that we haven't looked before in other tutorials. It's the t distribution table. And it is a little bit different. As you can see, there are two things we need to take into consideration, two parameters we use to find our value in the t table. And look at that. I will open and I'll ask you guys, the table is pretty long. It starts with the degree 0, I think 1 degree of freedom. I already cut whatever interests us, but I'll ask you guys to put on chat as usual, the value that we find for a t with these parameters, okay? And then we'll do it together. Well, where's the chat? There we go. Can I please have the value? Just put my chat in the corner. I haven't received anything yet, but let's have a look. If it's the first time you are you're doing it, thank you, Harry. It might seem a little bit trickier. It is a little bit different for the t distribution. Nice, Minken. Very good job. So let's do it together. First, we have a 0.005. So you already know t is 0.005 here. There's no, I think I have an extra 0 that they are not showing, but it's implicit, right? There, the point comes after the 0. Now we're looking for the 69 degrees of freedom. The degrees of freedom is here. So we go down to 69, make a line. My line is not straight at all. And then we go here. Look what we find, 2.649. Good job, you guys both got it right. And let's go look at that. So we have the value. This is the value here, positive 2.649 and minus 2.649. Look how similar the equation still is. X bar plus or minus t, our t crit, which is alpha divided by 2 and degrees of freedom, times s of x bar. So we have our sample mean plus the t crit times the sample standard deviation instead of the population standard deviation, right? little difference here. The t-crit, we have the value. We use the same as a z-crit. And this sample standard deviation, it's calculated, this SX bar, it's calculated by dividing S that we found by the size of the size of our sample, right? The square root of the size, which is n. So I'll click. So 175.9 plus or minus 2.649 that we found times 38, which is a little s, 38 square meters, and our sample standard deviation, and square of 70 there. And we find for our mu, it's between 163.8686 and 178.9315. So look at that, interpret this confidence interval. Let's go. Based on the sample mean, and maybe you could say based on the sample mean and the standard deviation, the average size of a single family houses is single family houses, so all of them, is estimated with 99% confidence to be between 163.9 and 197.9 square meters. This is interpretation. What assumptions we have what assumption has been made? We had to make a few assumptions here. First, we're considering that the size of the houses is normally distributed. So house size of single family houses, which is the variable, is normally distributed, or at least it's not highly skewed. Let me do a little bit. So we want it to be something like this, or at least not to be something like this, to skew to the right, or something like this, which is skewed to the left, right? That's what we don't want. Then this is necessary since we're just using the t distribution. Only the sample standard deviation is known, which requires sample to come from a normal distribution if the sample size is really small, right? And finally, more robust. It is more robust when sample size is large, provided the population is not highly skewed. So if it's not highly skewed, it will be more robust. And then there is a last question. What effect would increasing the sample size have on the precision of the interval? We've been talking about precision up to here. And increasing the sample size, look at this guy here, where it is in our confidence interval. Increasing the sample size would make the confidence interval narrower. Therefore, the interval estimate is more precise. So we have a confidence interval that we just generated. If we increase the sample size, the interval will shrink a little bit. And look why it shrinks, because it's in the denominator of our calculation, of the number, which multiplies. So we have the point estimate, our sample mean. Then we add and subtract something. And this something gets smaller every time we increase n, or gets bigger if we decrease n. So having a smaller confidence interval makes our estimate more precise. So if I told you a completely different example, if I told you, I will tell you the average age in Australia based on these two people here, the age of these two people. So just 2 is my sample size. So probably will not be very precise if I get just the average of those two. But if I tell you, I got this sample out of 2 million, a much bigger sample size. Therefore, out of 2 million, probably we can get very close, confidence interval, very close to the correct value. Okay, so that's what we're talking about. Increasing the sample size makes it more precise, therefore decreases the confidence interval. All right, I've said enough about this question. Let's go to the next one. The next one, let's put it all together. So find 95% confidence interval for the proportion of houses that have air conditioning. Now we're talking about air conditioning. Interpret. And what effect would an increase in the confidence interval have on estimate? So we know the amount of family houses, the level of confidence is now 95%. Alpha would be 100% minus 95%, which is 5%. We can paint it here, 0.95, the area at the tails. This is the area we're looking for. And we're talking about air conditioning. What do we do with this 42? It is actually a proportion question. So this is not a shag anymore. It is a freaky fish. So I replaced the things here. And look at this little detail here. We had nothing. Now, instead of a T, we'll be using a Z. But what's our P hat? Where is it coming from? So P hat is the 42 houses with air conditioning divided by the total of houses surveyed with 70. So 42 divided by 70, which is equals to 0.6. The advice here to realize this was talking about a freaky fish or a proportion is because it's saying proportion, right? Sometimes it might not be saying, but this was very clear what we're talking about. So let's go to find our Z grid for 0.475. Can I please have a chat 475? .475. It's increasing this way, right? What is the Z crit value for 0.475? Amazing. Thank you, Mikin. Exactly. Thank you, Harry. So let's click. There you go. 1.96. Oh, actually, slightly different, but good job, guys. You did really well. Actually, 0.475. We have the precise number there. Very good job. 1.496. Well, you got me actually with the 1.95 first. Good job. So let's go. We know the Z crit is 1.96. Then we can replace, look at the formula, same as we used before. P hat, we have Z crit, we have our sigma P hat. So we can replace the value 0.6, 1.96 and do the calculation for our sigma P hat that we have here. And we get between 0.48 and 0.7148. Okay. I'm just accelerating a little bit because it's already 5:18. So based on the sample, interpreting, based on the sample with 98% confidence, the proportion of houses with air conditioning is estimated to be between 48.5% and 71.5%. Okay? That is it. If you guys have now another question. What effect would an increase in the confidence level have on the estimate? So we're increasing the confidence level. What was confidence level? It was 95%. Because it says 95% confidence interval, right? If we increase it, what variables in our calculation of our confidence interval are impacted? P hat does not depend on the confidence interval. Neither does sigma P hat. It also doesn't depend. The only thing that changes is our Z crit, because it's the little area, right, that we're looking for. Remember, so if we expand the 95%, therefore this guy will be a little bit bigger, and which means these guys will be the absolute value will be bigger. So this one will be to the right, bigger, and this one will be to the left, more negative, so smaller. So the only one that is changing is that crit, and it's increasing. So look at that. As Z critical increases, the width of our confidence interval will increase. So when you look for 95%, if I ask you, give me the 99% confidence interval, then it will be a little bit larger. And being larger means it is less precise. Remember, as we were explaining before, the smaller and closest to the point estimate, the B hat or the X bar, the closest one, more precise. So if it's going a little bit further, it's less precise. But in this case, it's becoming less precise and wider confidence interval because we want to encapsulate 99% of the positions that we could find mu, or it means we want to find 99% of the samples that could have mu inside of it, or in this case, instead of mu, it would be P, okay, the population proportion. And whoop, that's it for that question. Do you guys have any question? Feel free to jump in. I will move to our last one since it's already 5:21. Okay, so very quick thing. Poll, just 1 minute. Each of maybe 2 minutes. 1 minute each of the polls. Is that all right? Just true or false. Very simple. As we have 21 people, so I'm expecting a lot of answers. I've launched it. As the width of an estimating interval increases, the degree of confidence in it actually containing the population parameter being estimated also increases. So as the width of an estimated interval increases, the degree of confidence in it actually containing the population parameter being estimated also increases. I have 12 answers, another 20 seconds. I'm missing 9 people. I'm missing 7 now. It's either true or false. So if we read another 10 seconds, estimating interval increases. So our confidence interval as it increases, the degree of confidence increases or decreases, right? Good. I will end the poll. I have 19 answers. Just missed 2 people. Amazing. It is true. Good job. So let me click here. Look, I got this little plot from this website. And if we're looking at a 90% distribution, it's 1.65 each side, right? For the Z table. If we want the 95%, we need to increase a little bit more. And if we want the 99% and a little bit more, and if we want 100%, you need all the way to infinity. So minus infinity and plus infinity. So it is true. That's what this question is talking about. I'll stop sharing and I'll launch the next one. Good job, guys. B, launch. Let's go. So other things being equal, the confidence interval for the mean will be wider for 95% than for 90% confidence. So the confidence, if we're talking about 95%, the confidence interval will be wider than the 90% confidence. I have 8 answers already. I'll still give you guys another 30 seconds. Think about it. What are we talking about in this one? Confidence. If you're watching it later at home, please give it a go too in your mind. Try to think what the answer would be. Just true or false. Will you guys have another 10 seconds? 16, 17 answers, 18 out of 21. Just missing 3 people. 5 seconds. 2 people missing, and that's it. 19 answers. Fantastic. Thank you so much. I had a split between true and false. It was 10 people said false and 9 people said true. So tricky question. This one is also true. So as we did before, other things being equal, the confidence interval found for the mean will be wider for 95 than for 90% confidence. And the previous plot that I had, was was there showing showing the answer. It's a little bit wider for 95. Okay. And here it is. As we increase the level of confidence, Z crit goes up, as we saw before, and the width of the confidence interval goes up. Right? I thought I shared the result. Okay, there we go. So it was very split. I'll stop sharing. Let's go for the next one. Sorry for sharing, kind of sharing the answer already. Next one. If the 95% confidence interval for the mean was found to be 3.7 to 9.2, then, and let me interpret it for you, the probability of X bar being between 3.7 and 9.2 is equal to 0.95. So if, let's go again, you guys have another, I have just 10 answers and you have 20 seconds to give your answer. So if 95% confidence interval for the mean was found to be from 3.7 to 9.2, then the probability of X bar being 3.7 and 9.2 is equal to 0.95. I got only 15 answers now. Another 5 seconds. And that's it. That's getting trickier. This is false, and I'll explain why. So I got 9 answers saying true and 6 answers saying false. This is a very tricky one. So usually you would first, confidence interval, it's not talking about probability. It's talking confidence interval and probability are two different things. And usually what we're looking for is not the X bar, but we're looking for 3.7, the mu. Oh, let me just use 3.7 smaller or equals a mu, smaller or equals than 9.2. But this is not a probability. There is a 95% chance that this happening is the wrong thing to say. In fact, mu is there somewhere, right? And we have 95% chance to fit our confidence interval. This is the X bar, to have the mu inside of our confidence interval, but it's not like the mu that changes. It's actually our sample that changes. Okay, so we never say there's a 95% chance that mu is there, as you saw describing before. So we could have our sample here, and we could have another sample here. Okay, all of them have mu, but the 5% that we don't have would be this sample, or maybe these other sample. Okay, they don't have mu. So that's what we're talking about. These are the two motives this thing is wrong. One, we're looking for where something around mu, and we never talk about probability when we're discussing confidence intervals. Okay, I'll clear the drawings. And finally, let's launch the last one. We are about to be done here with the tutorial. So it's not allowing me to launch it. Why is that so? Not sure if I reached any type of limit. Stop sharing. Oh, sorry for that. Let's go. Oh, sorry, we're a little bit late. It's 5:30, but let's go. A 90% confidence interval built to estimate the population mean does not mean there is a 90% probability that the population mean lies within the interval. True and false. I have 10 answers up to now. This falls in the same category as we did the previous one. So another 30 seconds for you guys, 16 answers already. A 90% confidence interval built to estimate the population mean does not mean there is a 90% probability that the population mean lies within the interval. I have 20 answers, another 9 seconds, 8 seconds. For the last person, there's one person who didn't answer. Yes, with everybody, 21. Good job, guys. Let me share a lot of true. 16 people out of 21 said it's true, and 5 said it's false. And it is actually true. And I didn't even change here. Confidence interval is different than probability. And I'll be honest with you, it took me a long time to get this difference in my mind, to get around. But pretty much what I draw before, we found the probability is in the sample. So when you talk about probability, is the X bar, and it's the 3.7, 9.2, something like that, the sample. But like X bar is not between something. I'm sorry, I think this doesn't make sense for you. X bar is not a probability. We find it. If you have a sample, you just calculate the mean. So we find it, okay? But mu is just there, sitting there. There's no probability about mu. Mu exists. We just don't know it, but it's there. All right. I think I explained in different ways the same thing. But thank you so much for attending. Let me stop sharing the results. Today we went through, first, apologies for being a little bit late. Today, we went through describing the differences between a point estimate, so X bar and P hat, and the interval estimate, determine when it's appropriate to use Z statistics for interval estimation, and when it's appropriate to use the T statistics. We use the T distribution tables. We calculated intervals for population means using Z and T statistics, and we calculate intervals for population proportions using Z statistics, right? Thank you so much, guys. We'll stop the recording. Have a good one.